In this video, I'm going to talk about what is semi-supervised learning. You might have heard about what is supervised learning and what is unsupervised learning. So semi-supervised learning is just a combination of supervised learning. It's a combination of supervised learning and unsupervised learning. Okay. So supervised learning algorithms could be linear regression, logistic regression, decision tree, a random forest, or support vector machine. Unsupervised learning algorithms could be mostly the clustering algorithms, right? So how do we combine both these sort of algorithms to sort of improve the predictions? That's the essence of learning semi-supervised learning, and that's used in a specific type of data. Okay, so why are we interested in semi-supervised learning? Well, the label data is very expensive to get in many instances. So unlabeled data is quite cheap, and if you are familiar with supervised and unsupervised learning, you know that supervised learning is used when your data is labeled, right? And unsupervised learning is used when it's not labeled or unlabeled, right? It's not labeled. That means there is no target variable for unsupervised learning, but there is some target variable for supervised learning. Now getting data which is labeled, which has some label or some target variable, value for target variable, is quite expensive, and sometimes it's not very easy to get such data. Many times we have a small portion of labeled data, and there is massive unlabeled data. So can we use both combined in some way to improve the prediction? So that's the idea of using semi-supervised learning. So let's see how the data looks like. So here is an example. So we have a label data. So we have got target variable as gender, and we have been given the height and weight of individuals. So the idea is to predict someone's gender based on his height and weight. Now, 3 of the data points are labeled. That means for the first 3 data points, we know that the first data point is male, the second one is female, the other one is again male. So this is labeled data. And labeled data is easy to use. We can use supervised learning algorithms to find out somebody's probability or chances of being a male or female. But the last 4 data points, okay, these data points are not labeled data, so to say. These are unlabeled. We do not know for sure that whether this is male or female. So when we train the algorithm, when we train the model, we have to either use the labeled data or use the unlabeled data. But can we combine both? We all know how to use a labeled data using supervised learning algorithm to do a prediction or do a classification, and we also know how to do it using clustering algorithms using unlabeled data. But how do we combine both to do the prediction? And the prediction is we need to know the chances of or given someone's height and weight, whether he is male or she is a female. Okay, so this is all about data. This is a typical example of a combination of level and unlabeled data, where we would be interested in using semi-supervised learning algorithm instead of just supervised or unsupervised. We'll combine both. Let's see how we do that. So as I've already said, it's an attempt to just use unlabeled data as well as labeled data. It's just a combination of that kind of a data we just saw in the previous slide. And the aim of this is to improve classification performance. Okay, and also it could be a prediction, not just it could be a regression problem, it could also be a classification problem. And so unlabeled data is expected to improve the classification performance when used along with the labeled data. And which I've already said, it's difficult to get labeled data for many types of problems, but unlabeled data is very much there everywhere. right? Because you go and classify each data manually, it takes a lot of time. But you have that handy for a very small section, and you have unlabeled data. You just can combine both. It's used in many areas: web mining, text mining, video mining. These are areas where you have such a very significant uses of semi-supervised learning algorithms. So we will take an example, and we'll also see how this can be used. Well, the idea is simple. Okay, let's go back to the data first I showed you, and let's see what is the fundamental theory, or what is the foundation of semi-supervised learning. It's simple. So we have, the first section is this first three observations are the level data, and the last four observations. Of course, in the real world scenario, you will have a larger data set, not just 3 or 4 data points, because you cannot fit a model to this 3 or 4 data points. You will have obviously more. So the idea is that first use the level data and fit an algorithm. So we have this level data, okay, and then fit a supervised learning algorithm, and using that trained algorithm, try to predict the values of each unleveled data points. So for this one, 76 and 77, try to find the predicted value of gender. It could be male. Let's say this is predicted value of gender, male something, and this it could be female, this could be again male. So build your model, train your model using level data, and use that to predict the value of the target variable for the unleveled data. Okay, now this data is also now level using the training algorithm we just trained in the level data. Okay, now this is not accurate, this is accurate, but these are all predicted values. Okay, so what you do in the next step is that you just include them in the level data as if they are level data, and then retrain the algorithm, and you go on doing that till the time you achieve the convergence. We define some convergence criteria, and then you use that, and you will see the accuracy or the prediction power of this model is better than the first model that we trained using just the level data. Okay, so the idea is to outperform the accuracy of the training algorithm used only for the level data. Okay, so these are the steps to be followed. Okay, so in this example, what you do is that there's this example of classifying documents. This semi-supervised learning is used quite heavily in classifying documents, classifying web pages, because you do not know for sure that what the level of this web page is for a number of web pages. So that's used. So in the first step, we just use an abbreviation, which is supervised learning algorithm, to model the level data. As I have already said, the first step, use the algorithm, supervised learning algorithm, just to train the model in the level data and get the model. Okay, you will get some form of model, right? You will get some form of beta plus beta 1x, something like that, right? Some supervised form, and then use this model, the estimated value of these things, on the unleveled data. Okay, and find the class probability, or the probability of that data point falling into some category, right? We call that as an expectation step, expected probability, right? Using this model, and then train the same naive algorithm again by including this expected value or the estimated value of the unleveled data with the level data. Okay, and you keep on repeating this step 2 and step 3 unless we get a convergence. Okay, that's what I explained previously. Okay, so this will have successfully applied to document classification. So document classification is a typical problem which can be separately solved using supervised and unsupervised learning, but combining both has a better accuracy. So like the attributes could be it could be some keywords like someone's supervisor is there, PhD topic is there. So it indicates that it's a faculty's page, right? It's a professor's web page. Okay, so that's the label to be assigned, but it cannot be done for all pages. So many times the data is unlabeled. Okay, so use the supervised class of algorithms to find out the labeling of each pages. And then you include the unlabeled data with the labeled data and continue retraining the model till the time you find most a better accuracy or some sort of convergence status is met. Okay, so we'll take another example. So this is also called self-training. So we'll see why it's called self-training. So here's an example. We use some classification algorithm to find out whether it's some sort of a it's an astronomical image, or it's just a car or something else. Okay, so the idea is to classify these images, and there's several images given. So what we do that these are classified. The first two images are labeled data. We know that this is an astronomical, this is a image related to astronomy, the other one is not, and that's well classified and given to us. And there are unlabeled data also, the one below. Okay, so we'll train a model or train an algorithm using this labeled data, and using that trained model we will find the probability or some sort of a score. We'll try to score each unlabeled data, and then using this score that we have found, we'll see which one is the most confidently we can classify. Okay, so we were able to classify 2 out of this unlabeled data, 2 images we were confidently able to classify. And how are we sure about the confidence level? Well, we just find out some criteria to be sure that a particular image has been confidently classified. It could be wrong though, but the most confident images will be included. Okay, and then you retrain the model again, and again you try to find out try to score the unlabeled images again and find out the most confident classified image, and then put that in the training level data again. Okay, and then you keep on iterating that, and you will see the accuracy level will improve over these iterations. Okay, now one catch or one issue with this sort of doing is that you are giving same importance to your label data as that you are giving to unlabeled data, right? And that's not a good thing, because label data is any day a better data than your unlabeled data, right? So when you are retraining your model, you should not give equal weight to the unlabeled data that you are giving to the labeled data. Hence, the weight or more weight should be given to the labeled data. So the weight given in the optimization algorithm should be higher towards labeled data than towards unlabeled data. So that would improve the accuracy.